Well, today's lesson is on isotopic notation. It's the second part of a three-part series in nuclear chemistry. And today's video is going to be talking about how you can calculate the protons, neutrons, and electrons in isotopes. So let's get started, first of all, with a couple of practice problems. And one of the things about notation that is listed here is we have two kind of conventions. Kind of the shorthand method, which is basically putting the element, a symbol, and then a dash followed by the atomic mass. That's one way of doing it. It's a short-handed way, but it still works. The other way is actually putting the elemental symbol and then the atomic mass and then giving the atomic number. And same thing over here, the elemental symbol plus the atomic mass and, of course, the atomic number. Well, how did I get this number? How do I know that there are the atomic number 7 in nitrogen? Well, I looked on the periodic table, and as you can see here, it tells me where the atomic number is. It's this one right here. The atomic mass is right here on this particular one. And all periodic tables are sometimes organized just a little bit differently as far as where they put their number. But on the isotopes, as far as the notation is concerned, the mass goes on the top, the atomic number goes on the bottom. Now, what does the atomic number mean? Well, way back in September, October, we went over that. But just in case you need a refresher course, atomic number means the number of protons. And if they're balanced or stable, then it also means the number of electrons. Whereas atomic mass means exactly that, the weight of the mass. So now that we got that kind of taken care of, let's take a look at the number of protons. Number of protons in nitrogen-15 are 7, based on the atomic number, just like we said right down here. And in for nitrogen-20, it's the same number. The thing that makes elements, those kinds of elements with kind of the same characteristics, is the fact that the atomic number is the number of proteins. Proteins is the thing that kind of makes that particular element special and has a special characteristics because of the number of protons. Now, if you watched the first video on the definitions of isotopes, you would have learned that. If you haven't watched it, you may want to go ahead and stop this video and watch that one so you get some of the basics that you may miss here. All right, that brings us to the number of neutrons. Now, remember, the atomic mass is the number of neutrons plus the number of protons. That is what the atomic mass is all about, right here. Neutrons plus protons. Now, atomic number is just the protons themselves. So to figure out the number of neutrons, I'm going to have to take the atomic mass, and let's start with nitrogen-15 first. Take 15, we're going to minus 7. We're going to subtract out the protons, and that'll give us the number of neutrons, which in this case is 8. So it's a little bit, it's going to be a little bit lighter than this one because this one has an atomic mass of 20. I'm going to subtract out the protons, which is 7. Found the atomic mass. That's going to equal 13 neutrons. 13 neutrons. So as I said before, because it has a higher atomic mass number, there's going to be more neutrons. And that's the thing that typically will change. Sometimes the electrons do a little bit. I'll show a couple problems where the electrons do change. But for the most part, because they're stable elements, we're going to balance our protons, which are, of course, positive, with electrons that are negative. So this is also going to be 7. So just a quick reminder, there are two different kinds of notations. The shorthand method, where you take the elements symbol and you put a dash and then the atomic mass, whereas on this more conventional one, it's the symbol plus the atomic mass at the top, atomic number on the bottom. So that's really how we would do a more, I guess, a traditional kind of a problem. Now this next one has a few things missing. First of all, you'll notice there's no element up here. We don't know what the element is. We don't know the notation quite yet. So we're going to be looking for those two things, what's going on. But if you take a look, it does give us the number of protons. So because of that, we know the atomic number is, that's right, 32. And so we go ahead and look on the periodic table, and there it is, 32. Germanium. Germanium then has this atomic number 32. It has atomic mass of 72. But remember, the atomic mass equals neutrons plus protons. And in this particular case, as you can see here, it's protons and neutrons. That's going to be adding up to 62. So the atomic mass for this is going to be 62. So we know that it's going to be G, E, and a small case e because it's one element. Put a dash, and we added those both together. We added this to this, and we get up here 62. So I took 32, which was a number of protons, plus a number of neutrons, got 62, and that's what ended up over here. Now we also know that this is 32 because this particular element, germanium, has 32 as an atomic number, so there's 32 protons, 32 neutrons, so it's 32 plus 32. That's going to give us 64. So the isotope for that one, capital G, little e, not a big E, because that means it would be a different type of element, and it's going to have dash 64. And because it doesn't have a charge, both of these will be 32. So far, it's been fairly easy. Let's kind of step it up a notch, and let's put a charge on something and see if it makes any difference. Okay, here's magnesium. Now, magnesium, if you notice, it has the atomic mass right here. It's 24. That means it's neutrons plus protons. This is protons. But what's different now is 2 plus. That means the electrons are going to be somewhat different. So let's go ahead and take a look over here. And we're going to put, first of all, the protons. The protons, as we noticed before, is 12. All right. Now what we're going to do is going to figure out the neutrons. That's 24 minus 12. That's going to be 12. So it's going to be 12 neutrons. We have 12 protons. Now, if this particular magnesium was stable, that would actually be a 0. And because of that, that means our electrons would equal also 12. So, in a stable state, let me rewrite this. Protons equals 12. Neutrons equals 12. And electrons equals 12. But we're not in a stable state. We have a charge we have to account for. So how many electrons are going to be in this charge? Well, according to this means that we have to have 2 more protons than we do electrons. Because remember, protons have a positive charge, electrons have a negative charge, and to get 2 more positive charges, we need to have 2 more protons. Now, we can't change the protons because if we do, it changes this element to something else. So we're going to actually take away some electrons. So we know that this is 12. There would be 12 electrons if it was stable, and we're going to subtract 2 of them because that's what it says up here, and that's going to get us 10 electrons. So for a charge element of 2 plus, we're going to have protons are 12, neutrons are 12, and electrons will equal 10. This one right here best describes magnesium with a +2 charge, or 2 plus charge. So that's how you would calculate one of those if it had a charge on it. Now let's look at something a little bit different. Let's say we don't have our element. In this case, the element is missing. We don't know what element it is, do we? So we have this big question mark. What is it? Well, you should look around and you can see here's a huge hint right here. Atomic number 17. Well, what is atomic 17? Well, we need the periodic table to find out. So we're going to call in the big boys here. And here is, let's see, here it is. 17, atomic number. Chlorine. So we're going to go ahead and get rid of that real quick. And now we know what we're working with here. Now because it is, I'm going to bounce right in there. There it is. Right into place just like I asked it to. We know right now that we know this is a 17. That's the atomic number. Now what we don't know is the number of protons. The protons are missing here. Well, are they really? Here's the atomic number. So we can call that 17. But we still need the atomic mass, and the atomic mass is neutrons plus protons, and so that would be 18 plus 17, and that's going to equal 35, and that will be our atomic mass. Now in normal situations, this would be 17 positives, and electrons would be 17 negative to balance it. But this is 18 electrons. Now what are we going to do? Well, this means there is one more electron than a proton. So if you just take 18, subtract the 17, we're going to have equals 1. That means it's going to have a charge of 1 minus, because it has a negative charge and it has to have one more electron than proton. That's going to give us a 1 minus. So that would be the charge. So as you can see, it takes a little bit of forethought, and it takes a periodic table. But really, once you have the basics down, as I showed you in the first slide, it should be relatively easy to figure out neutrons, protons, electrons, and even charges. So I hope that's helped. And the next video is going to be on radioactive decay. So we'll see you soon. Thanks.